Hello students, welcome to this class of fluid mechanics. So in last class, you must remember we have studied about velocity stream function, and the class before that we have studied about velocity potential function. Fine. So the coming topics are also related to these both functions. We are going to study two lines, basically the equation of two lines. One is equipotential line and the another is constant stream function line. This class is on equipotential line. Fine. So what is equipotential line? It is a in last class we have studied a potential function, right? What we have studied in last class? In last class we studied velocity potential function, right? We studied that fluid flows in the direction of decreasing potential function. Fine. So let's say this function is phi. It's a function of x and y, right? Phi. This is a velocity potential function, let's say. Fine. So what is equipotential line? Equipotential line is the line at which potential function remains constant. Fine. What does it mean? It means phi is equal to constant. My potential function is constant here, right? Or I can say that, which also implies d phi will be equal to 0. Fine. To write the equation of equipotential line, first of all, what is equipotential line? The line at which potential function remains constant, which implies phi is equal to constant, which implies d phi is equal to 0. So if my phi is equal to function of x and y, I can write d phi as del phi by del x into dx plus del phi by del y into dy, right? It's quite simple. Now we also know, as we have studied in the class of velocity potential function, that del phi by del x is equal to minus u, right? And del phi by del y is equal to minus of v. So let's put these values, right? So now we will put these both values here, this value in this and this value here. So when we put these values, what we will get? We will get d phi is equal to minus of u dx minus of v dy, right? Now for equipotential line, d phi is equal to 0, right? So I can say minus of u dx minus of v dy is equal to 0, right? For equipotential line, that is the line along which my potential function remains constant, right? So here, what does this imply? This implies dy by dx is equal to minus of u upon v. This is the result that we were looking for. This is the slope of equipotential line. Fine. This is the slope of equipotential line. dy by dx is equal to minus of u upon v. What does it mean? That the line that has this much slope, along that line my potential will remain constant. Clear? Well, in next class we will study about velocity stream function. Bye bye. Meet you in next class.